Hi. Unit 14. Mr. Schroeder did the demo at home, mostly because he lives in Crystal Lake and he's close enough that he can go and take equipment out of our prep room. But now no one's allowed in school, so I'm not sure what he's going to do for the rest of the demos because they're having asbestos abatement in the science wing. So we'll just figure it out as we go. Okay, so from the video yesterday, this is the table that's super, super important. I'm going to give you a copy of it. It is the key to the whole unit. So yesterday with the light bulb, when you put hydrochloric acid in the light bulb, yes. Can you see the green? Maybe not so good. Let's go blue. Yes, it definitely lit up and it was very bright. And that was with the 25-watt light bulb, right? And we talked about the resistance yesterday on the light bulb. This is an acid, and we know it's an acid because it starts with hydrogen. This is a base because it ends in that OH, so hydrochloric acid, sodium hydroxide. Hydrochloric acid is a strong acid, and sodium hydroxide is a strong base. So then this also, yes, it was very bright. Okay. Then we got to this one, and that's acetic acid. It's the acetate, the CH2 ion with the hydrogen. And when you did, we had to change the light bulb lot, but yes, this lit up, but it was dim. Okay. Initially, yes, the tap water lit up, but it was also kind of dim. And the distilled water initially, no. The only way you got the distilled water to light up was when you changed it to the 2-watt light bulb. Okay, so this was dim. This would be very dim. And then this, when you went with the 2-watt light bulb, it was very, very dim. Okay, key question, why? Why was it so bright up at the top, and then why was it so dim at the bottom? Are you thinking? Good. Okay, the reason that it was dim was because there was few ions. Okay, the ones that were really, really bright had lots of ions. It fully ionized, so that hydrochloric acid, when you put that in the water, it fully ionizes and it's very bright, lots of ions. But this one, oh my gosh, in the beginning of the school year, we said that it had no ions, and now we know it has a little bit of ions, but not very much, very few ions, so then therefore it is very dim. So now the question is, okay, so that's great, Mrs. Mizuko. What are we going to do about it? Well, this unit, yesterday you did a little research on acid and base. Today, we're going to talk about equilibrium. And so it's not, remember that a normal chemical equation, it's a one-way street. It goes from the products to reactants, but we learned that most of the time it's kind of in equilibrium. So it's a two-way street. Some of it's going back. So let's start with the acid. So, hydrochloric acid broke apart into the H plus ion and the Cl minus ion. It was a very bright light. This definitely fully ionized, so this is a one-way street. So there's no equilibrium. Okay, this produced lots of ions. Okay, the next one, sodium hydroxide. Same thing. Here you have the sodium ion, the hydroxide negative ion. Remember, this is what makes this an acid. This is what makes this a base. This was also very bright, which means it's a one-way street. There's no equilibrium. Right? None of it's going back this way. It's all going this way. You get lots of ions, not at equilibrium. So this, because it's it fully ionized, we call this is called a strong electrolyte. And I always think of electrolytes, I think of Gatorade, right? And we have to replenish your electrolytes. You got to replenish those ions. This is a strong electrolyte. Up here, this one also is a strong electrolyte. Bright light, strong electrolyte. Both of these right here, you can write yourself a note off to the side. Both of these had complete ionization. Oh, I think I'm in the way. Okay, so complete ionization. Bright light, one-way street, no equilibrium, lots of ions, strong electrolyte. Both of these. This one's an acid, this one's a base. They're both strong electrolytes. They're actually both considered strong acids, or strong acid and a strong base. Okay, now let's go with acetic acid. So the acetic acid was not a strong light. The acetic acid okay, so this was a dim light, which means few ions, not a lot of ions, just some ions. It lit up. Okay, so because it lit up, we know that it has some ions, but it wasn't bright. So because it's not bright, we know that some of the ions are going back. Okay, so some of these ions, they're going back. So this is not a one-way street. This is a two-way street, which means this is an equilibrium. Okay, remember the rates of opposing reactions are equal, so the rate of it going this way is equal to the rate of it going this way. There's only a little bit of ions. It's not as bright. It's at equilibrium. So this is considered a weak electrolyte. Okay, and this is only partial ionization. Okay, so then the very last one was the distilled water. And we are like, distilled water that has no ions. That's why we run it through that machine. But distilled water actually has a little bit of ions. So here's your water. This was super dim, so we know it's got to have 2 arrows. Breaks apart into the H plus and the OH minus. Oh my gosh, this, that means it's an acid. This means it's a base. So water has both the ion that makes it an acid and a base. Hopefully you remember from biology that water, distilled water, is actually neutral because it has the same amount of this ions as it does this ions. So this was dim, which means that it has few ions, only partial ionization. Okay, that tells us that this is a two-way street. Some of it's going this way, some of it's going this way. So that means that it is at equilibrium. Okay, and then this is another weak electrolyte. And remember, water is considered neutral because the concentration of H plus ions is equal to the concentration of OH minus ions. Okay, that's where we're going to stop for now. We'll pick up here tomorrow.